Hello. Welcome back to this session. We are still looking at carbohydrates, but now specifically we have been looking at the starch as a polysaccharide. We looked at starch and said starch exists in two forms, amylose and the amylopectin. So we want to first compare these two starch forms. What would be the similarities? Similarities between them, between amylose and the amylopectin. Between amylose and amylopectin. One, said that both consist of alpha, which we do not have this, alpha glucose units. That's one. Then two, both contain a 1,4 glycosidic bond. Those are the similarities we can find so far. Then the differences. Are, if we tabulate them, we put amylose on one side and the amylopectin on the other side. Find that number one, the main difference is this one takes up a helical shape. It takes up a helical shape. Amylopectin is straight and branched. Straight and branched. Two, amylopectin, rather amylose, has only 1,4 glycosidic bonds. Amylopectin has 1,4 and 1,6 glycosidic bonds. 1,4 and 1,6 glycosidic bonds. For that, that's the comparison between amylose and amylopectin. We will find the others will be in chemical properties, but not structural comparisons. Of course, being that the type of bonding is different from each other, it would mean they have different chemical properties, and therefore also physical properties, because the number of sugar units they will be containing is varying from one starch to another. So let's look at the test for starch before we leave it. Test for starch. We will tabulate our tests in a table. Test for starch. We get the observation. Observation, then conclusion, and this is the test procedure. The test procedure. So we say to 1 cubic centimeter of the test solution. The test solution can be the food substance you are investigating to see whether it contains starch. Add 2 to 4 drops of iodine solution. So iodine solution appears brown. It appears brown, so it would mean the solution, when you add iodine, the color changes would appear. So here we would have the solution turns to blue black, there you will say starch present, or the solution turns to a brownie solution, there we shall say starch absent. So the color changes will have changed to that extent. So we look at the function of starch. How is starch useful, and how does it suit for its function? The function of starch. So said starch is a storage carbohydrate. In plants. It is found sometimes stored in the chloroplast or in cells within storage pads. Storage pads like tubers. So it is found there. So briefly we can now say why starch is a better storage molecule than other carbohydrates. Because we have very many carbohydrates, as we have so far seen. We have glucose, we have sucrose, we have maltose, we have all those monosaccharides we looked at. Why is starch a better storage molecule than them? One is that starch is more compact. So starch is more compact than the rest. So it means if it is more compact than the rest, it fits in a small space. Meaning a lot can be compacted in one place. So that one gives it an upper hand over sucrose, over other carbohydrates we're going to discuss, the cellulose and glycogen. Then also, starch is insoluble. Starch is insoluble in water. How is this of importance to cells that store it? The starch being insoluble in water makes it not to interfere with the osmotic potential, of the cells storing it. And lastly, what makes it more and more important in storage is it is inert. It is inert and so can be stored for a longer time. For a longer time. Compared to other carbohydrates, starch is inert. So in our next session, we shall talk about other polysaccharides, including cellulose and glycogen.